I'm Julianne Ponder. I'm a business development manager with SCD Probiotics based in Kansas City. I focus on industrial applications like agriculture. I also support our Latin American licensees. Today I'm going to speak to you about probiotics in tobacco farming. We had a little bit about it this morning from Macedonia. I'm going to elaborate on that and talk about a project I worked on in Latin America. So first I'm going to do an introduction on setting objectives and the different things you can do with probiotics in agriculture in general. I'm going to do an overview of the tobacco projects that we've done around the world. And then I'm going to focus on Colombia, South America case study and talk about some tobacco opportunities globally. There are over 4 million hectares of tobacco grown worldwide. It's a huge opportunity, a very interesting crop, and as you've seen this morning, we have some great data on it thus far. SCD Probiotics is a unique value proposition in restoring soils to a more healthy state and reducing the amount of chemicals used. In this most recent project, we've worked on not solely increasing yields, which has been a lot of the focus in the studies I've read and been involved with. Really, we were focusing on lowering the amount of fertilizers used for multiple reasons. We wanted to lower the amount of costs per unit or per hectare, and we also wanted to decrease the dependence the world has on these chemicals and synthetic fertilizers that are being used. There's been some work done on tobacco here in Poland. I haven't been personally involved with it, so I'm going to go over some of the highlights of what I've read and learned. There's been an increase in soil quality, specifically magnesium and potassium. There's over 5,000 farms that have been trained on using SCD probiotics for tobacco cultivation. Some major benefits that they've seen here. The first is accelerating the breakdown of crop residues. They leave them in the field, apply SCD probiotics to them. They break down faster and till them into there. Prior to that, they were still having some large debris and large residues remaining over winter. They also had some pathogen control results. Specifically, some of the diseases they worked on were rhizoctonia, different fungal diseases, and thrips in the greenhouse applications. Now, you saw Macedonia this morning. I put this in here because this is one of the financial results of this, and it was very impressive to me. They had multiple benefits throughout their applications. 25% increase in yield. They had an increase in tobacco quality. The chart here shows the two regions they worked in. They got up to a $6,846 profit increase per hectare, which is a huge result. They also talked about all the benefits realized in multiple facets of the industry. There was many effects all the way down the line of increasing the quality of tobacco by using SCD probiotics. I had the pleasure of working on a project in Colombia. I got to be involved from start to finish and help design some of the parameters and really got to be involved. So I have a lot more ownership in this. This is a picture on the farm here in Colombia with some of our licensee there, some of the helpers, and some of our partners. This is in Villanueva, Colombia, which is the northern region where tobacco is grown there. It started in September of 2010, still going on. The tobacco is burley with the specific variety, Colt Tobacco 54M LC. Our partner with this was Naturalis, our licensee in Colombia. They have been a very essential partner. They've helped us. They've moved a lot forward, and they've given perfect technical support. The products used were SCD Bioag, Bokashi, and Tabacaza. And I'll talk a little bit more about specifically what Tabacaza is here in a second. So the objectives. It's very, very important for any application of probiotics, but especially for agriculture, to define your objectives. What do you want to do? It's easy to put it on the field and then see 6 to 9 months later, well, this improved, but we don't really know because we didn't compare it before. We were very specific of defining our objectives for this project. We wanted to lower the input of synthetic fertilizers used or inorganic inputs by 25%. And we also wanted to maintain or preferably increase yields while lowering that input. Also, they had very poor soils here, very low humus content. So we wanted to see some residual effects over time of improving their soils. We had 4 test areas. The first one I'll refer to going forward as T1. It was the highest application of SCD probiotics. It included probiotics and a standard application of fertilizers and other synthetic inputs. We used 20 liters per hectare of SCD BioAg liquid product, 30 kilograms per hectare of bokashi, and 300 kilograms per hectare of tabakaza, which is a solid form. It's the crop residues inoculated with SCD probiotics, then applied to the soil and tilled into the top few layers. T2 was the same inputs as T1, but the liquid probiotics were inactivated. We heated them to a certain temperature for a certain period of time to show that it's actually the live microorganisms that are doing the job we want them to, not other byproducts or other things in the product. T3 is a lower portion of SCD probiotics. It's 5 liters per hectare of SCD BioAg, 7.5 kilograms per hectare of bokashi, and 75 kilograms per hectare of tabakaza. T3 was also a 25% reduction in fertilizers applied to this treatment. T4 was the control, standard inputs applied, as the rest of the farm was, and how they've done it for years now. Here's some pictures of the product applications. This is application of the liquid product, SCD BioAg. They used backpack sprayers and applied it to the tilled soil. This is application of SCD bokashi. They used wheat bran inoculated with our microorganisms. This is application of tabakaza, which I mentioned is crop residues, leftovers from the last harvest from the tobacco that they inoculate, compost with our probiotics, and then apply back into the soil. The parameters measured for this project were, we did soil analysis before and after. We did morphoagronomic evaluations, both at 60 days and 70 days after topping. Green and dry weight of the roots. The average price and average kilogram per tobacco. And we did a cost-benefit analysis per treatment, keeping very close track of how much we spent for each treatment so we could compare it. So here's some of the results. As you can imagine, we got results coming in as the season was going on, so I'm going to go as we got the results. So the first was the morphoagronomic treatment after 60 days. You can see here from this chart both the height, the number of leaves, and leaf 6, the length and width of the leaves. Treatment 3 was the most successful treatment. This was very exciting news given the lower application of SCD probiotics that we used, and this was also the one with the reduced percentage of inputs. Continued on with the morphoagronomic results. This is 7 days after topping. Once again, you can see treatment 3 had the best values, had the highest height reported there in centimeters, the largest number of leaves, the distance between the nodules, and the leaf average again for the length and width was largest for T3. This was all leading us basically to show that we were, with the probiotics and the reduced amount of synthetic fertilizers, we were producing very healthy plants. Results after harvest of the green weight and dry weight of roots, also very positive. You can see in the picture, I don't know if you can see my numbers here. This is 1, 2, treatment 3, and treatment 4. Treatment 3, once again, had the highest values both for green weight and for dry weight. It was a 75% increase over the control, the average weight of the root system. Now, this is one of the most important features and one of the objectives we set for this project. That's the cost per hectare of the different applications. You can see here that for T3, it was the lowest input cost per hectare, with maintaining a high quality index percentage there. You can see that after we got all the results and agreed with all involved with the project, there was no statistical difference in yield and quality between T3 and T4. There's $147 additional profit for T3 per hectare. So we were successful in lowering the cost per hectare of inputs while maintaining the yield for them. We also can expect some further reduction in costs because this is a 3-year study. We're now concluding year 1, and we anticipate to continue to lower the use of synthetic fertilizers. So talking more about global tobacco opportunities. I said in the beginning there's over 4 million hectares of tobacco. There's many other different types of crops where this would apply to. I want to stress again how important it is to define your objectives, set us ahead of time, identify what are the biggest pains that they see, what can I help with the most, or what can I show the most benefits in the fastest way. A lot of time with agriculture, it's a lot longer cycle than some of the other application of STD probiotics. So you have to be very clear up front and get a lot of information from the customer and define what you want to do and how you're going to do it. What we found successful and what we're focusing on at this point is the cost-benefit analysis. For many soils in the United States and other parts of the world, they're very dependent on synthetic fertilizers. Now, they have their programs and these chemicals down to such a fine art that it's unlikely you're going to increase the yield, especially in a short period of time. They are receiving everything they could ever want in a very fast way. But it's not healthy long term. We all know it's not sustainable and it's not the future. But, as Matthew talked about, we are growing more, we need more and more food on less and less land. So we don't have an option to lose yield right now for sustainability. This is a very viable option to reduce fertilizers and chemicals used by using probiotics, but maintaining the amount of food and crops that are produced. This is transferable knowledge to any type of agriculture. I've been focusing on tobacco. Honestly, I have been working with it because I saw such positive trends and results and projects here in this part of Europe. So I wanted to take it to Latin America and see if we could grow. And that's why we were able to do that. But there are many other crops this would work on, virtually any of them throughout the world. Please follow us on Twitter. If you have any comments or questions or want to post anything about the conference, then there's our Twitter address right there. Thank you.
Dziękuję bardzo.